Let's solve some problems here. In the diagram below, segment AC has endpoints with coordinates A, -5, 2, and C, 4, -10. If B is a point on AC and AB is to BC is equal to 1:2, what are the coordinates of B? So in this problem here, we're given a point B on segment AC, and the ratio between segment AB and BC is 1:2. Now to solve for the coordinates of B, let's take note that the ratio is 1:2, so that means if this is point B, segment AB is shorter than segment BC. So if we're going to divide segment AC into 3, so that means segment AB is just 1/3 of AC and segment BC is 2/3 of AC. So to solve for the x coordinate here, we just have to add the coordinate of point A, x coordinate of point A, which is -5, plus 1/3 of the difference between the x coordinates of points A and C. So that would be 4 minus -5. So x is equal to -5 plus 1/3 times 9. So x is equal to -5 plus 9/3, and 9/3 is just equal to 3. So this is -5 plus 3. Therefore, the x coordinate of B is equal to -2. Now let's solve for the y coordinate of B. The same process. So y is equal to y here. Y coordinate of A is 2 plus 1/3 of the difference between the y coordinates of points A and C. That would be -10 minus 2. So y is equal to 2 plus 1/3 times -12, and y is equal to 2 minus 12/3, and 12/3 is just equal to -4. So this is just 2 minus 4, and this is also equal to -2. Therefore, the coordinates of B are just -2, -2. So the answer here is 1. Point Q is on segment MN such that MQ is to QN equals 2:3. If M has coordinates 3, 5, and N has coordinates 8, -5, the coordinates of Q are. So we use the same process or method that we used in the previous problem. Since we're given here the ratio between segments MQ and QN, if Q is a point on segment MN, which is equal to 2:3. So that means segment MQ is just 2/5 of MN, and QN is 3/5 of QN. So now we can solve that. We can solve for the coordinates of Q, x, y. So let's solve for the x coordinate first. So we're given here these 2 points. So that would be 3, the x coordinate of point M, plus 2/5 times the difference between the x coordinates of M and N. Times M and N would be 8 minus 3. So x is equal to 3 plus 2/5 times 5. 5 here cancels out, so we're left with 3 plus 2, which is equal to 5. Therefore, the x coordinate is just equal to 5. Now let's solve for coordinate y. So y is just 5 plus 2/5 times the difference between the y coordinates of points m and n, -5 minus 5. So this is 5 plus 2/5 times -10. And this cancels out. -10 divided by 5 is just -2. So this is just y equals 5 plus 2 times -2. So y equals 5 minus 4. So y is equal to 1. Therefore, the coordinates of Q are 5, 1, and the answer here is 1. Let's solve some more problems here. Line segment RW has endpoints point R -4, 5 and point W 620. Point P is on RW such that the ratio between RP and PW is 2:3. So what are the coordinates of point P? So the same method. Okay, so that means segment RP is just 2/5 of RW and PW is 3/5 of RW. So X is just -4 plus 2/5 times the difference between the X coordinates. So it would be 6 minus -4. X is equal to -4 plus 2/5 times 10. So 10 is divisible by 5, so this is just 2. Therefore, X is just equal to -4 plus 4, which is equal to 0. Now let's solve for the y coordinate. Okay, so this is 0. So the y coordinate is just, okay, y, the value of y, 5 plus 2/5 of the difference between the y coordinates of the 2 points, 20 minus 5. So this is just equal to 5 plus 2/5 times 15. And 15 is divisible by 5, so this is just 3. So this is y equals 5 plus 6. So y is just equal to 11. Therefore, the coordinates of point P are 0 and 11. So the answer here is 2. Directed line segment DE has endpoints D, -4, -2, and E 1/8. Point F divides DE such that the ratio between DF and FE is 2:3. What are the coordinates of F? So the same method. I hope you are now familiar with the method on how to solve problems like this for directed line segments. So the given ratio here is 2:3, the same. So therefore, DF is 2/5 of DE, and FE is 3/5 of DE. So we can solve for the x coordinate now. That would be -4 plus 2/5 times the difference, 1 minus -4. So x is equal to -4 plus 2/5 times 5. So this cancels out. So x is equal to -4 plus 2. So this is -2. Therefore, the x coordinate is negative 2. And now let's solve for the y coordinate of point F. So it'd be y equals negative 2 plus 2/5 times the difference between the y coordinates. So it would be 8 minus negative 2. Y equals negative 2 plus 2/5 times 10. And 10 divided by 5 is 2. So y is just equal to negative 2 plus 2 times 2 is 4. So y is equal to 2. Therefore, the coordinates of F are just 2 and negative 2 and 2. So the answer here is 2. The coordinates of the endpoints of the directed line segment ABC are point A, negative 8, 7, and point C, 7, negative 13. If the ratio between AB and BC is just 3:2, the coordinates of B are. To solve for the coordinates of point B, again we use the same method. Be this one, negative 8. Okay. Oh, let's take note for the ratio first. We're given the ratio which is equal to 3:2, so that means AB is just 3/5 of AC and BC is 2/5 of AC. So this is negative 8 plus 3/5 times the difference between the x coordinates of the 2 points. So it'll be 7 minus negative 8. So this x is equal to negative 8 plus 3/5 times 7 plus 8 is 15. And 15 is divisible by 5, so this is just 3. So x is equal to negative 8 plus 3 times 3 is 9, so x is 1. Okay, therefore the x coordinate of B is 1. And now let's solve for the y coordinate. So y is just equal to 7 plus 3/5 times the difference between the y coordinates of points A and C, negative 13 minus 7. So this is 7 plus 3/5 times negative 20. And 20 is divisible by 5, so this is just negative 4. Therefore, y is just equal to 7 plus 3 times negative 4, 7 minus 12. So this is negative 5. Therefore, the coordinates of point B are 1, negative 5. So the answer here is 1. I hope you understood everything about solving directed line segments on lines and angles. I will discuss the rest of the topics in the next videos.